Welcome back to our disaster management course. Myself, Dr. Nagalapuram Muni Pradeep, Assistant Professor, Department of Civil Engineering, SR University, and we are continuing our Unit 1, that is Introduction to Disaster Management. And today we are on Lecture 4, Part C. The first part A and Part B is about um, pre-disaster era, disaster preparedness. So our topic for this session is prevention strategies. So without delay, I'll start the session. So please go through the PPT slide. I'll give you 30 seconds. Then I'll start explaining each slide, each point in detail. Okay, I'll start. So in this slide, we are specifically discussing about the disaster prevention measures. So here, what is the prevention? The prevention means the actions taken to stop disasters from occurring or to prevent them from causing any harm. I'm repeating, the prevention measures means the actions taken to stop the disasters from occurrence, or if occurring also, the disasters to prevent them from causing any harm to the people. So this slide cites the high powered committee report, usually we called as HPC report on disaster management. So this HPC report is published in 2001. So what is the importance of this report? This is an important document in the history of India's disaster management policies. So this is a base for, this is a foundation for disaster management policies, all the key decisions taken by the government depending upon the HPC, High Public Committee report. And this is a groundwork for the introduction of Disaster Management Act, which is established in 2005. So the HPC report is a foundation for Disaster Management Act in 2005. So what is this HPC report and what it identified? So the HPC report identified 4 key prevention measures. So let us examine each one in depth. The first prevention measure was the risk assessment as a required foundation. The first prevention measure what HPC report reported, that is risk assessment as a required foundation for any disaster. So this the HPC report states very clearly that the risk assessment is required step for the adoption of an adequate and successful disaster reduction policies. This is the foundation stone. So this is a fundamental principle. So you cannot manage a risk you have not identified and measured, right? You cannot manage a risk if you don't identify and measure. The risk assessment is a systematic process of identifying hazards and analyzing vulnerability and exposures and estimating the probability and potential impact of disasters. Without this foundation, the prevention activities, the prevention mitigation techniques measures are just guesswork, right? So what is this risk assessment? How we'll do the risk assessment? So the risk assessment involves several steps. The first one is hazard identification. So what is hazard identification here? In hazard identification, we are mapping where earthquakes, the floods, landslides, cyclones and all other hazards are likely to occur, and with what frequency and with what intensities these hazards are about to happen. This all comes under the hazard identification. And the second one, that is exposure analysis. In exposure analysis, we are determining what the people, the building and all the infrastructure are located in that hazard areas. And the third important assessment, that is vulnerability analysis. In this, we are assessing the susceptibility of exposed elements to damage, and risk estimation, which combining these two factors. One is assessing susceptibility of exposed elements to damage and the risk estimation. The combining these two factors to produce a risk maps that guides all the prevention investment. Based on these factors only, we will invest the money on prevention activities. So in India, the National Disaster Management Authority has developed a national level hazard zones map for earthquakes, floods, landslides and cyclones. So you can directly take from the National Disaster Management Authority. So they have the details about the zone wise. So you can simply collect from them. The Geological Survey of India, which maintains landslide hazard maps, and the Indian Meteorological Department, they provides the flood and cyclone risk assessment maps. So at the local level, the district disaster management authorities are responsible for district level risk assessment. So they'll submit the reports to the state level, and the state level they'll submit to the central level. So the district disaster management authority, so they're responsible for disaster level risk assessments at district level. Through the quality and currency of these assessments varies greatly across different districts. So coming to the second prevention measure, that is, we are mainly focusing on reducing the need for disaster relief. This is one most important point. We are the HPC report makes an important and an often overlooked point, that is the disaster prevention should focus on reducing the need for disaster relief. What does that mean? I think it's a hypothetical statement. The statement is a direct challenge to the traditional relief first approach to disaster management. See, here the argument is very, very simple and very powerful. Every rupee spent on disaster relief is evidence of a failure of the prevention system. If you are success in prevention system, then no need to spend this much money on relief activities. So it was very, the argument is very, very powerful. The most successful disaster management system is one that has never to deliver relief, because its prevention and mitigation measures were so effective that no disaster of significant scale is occurred. So this doesn't mean that the relief is very unimportant or no important. When disasters also do occur, relief is an absolutely essential thing. See, but the goal of a mature disaster management system should be to be progressively reduce its dependence on relief by investing more effectively in prevention and mitigation measures. See here, for explaining this context, I'll give you one example, that is Japan. Japan is often cited as the world's leading example of a country that has made his shift. So despite being one of the most earthquake prone countries on the earth, I'm highlighting again, despite of being one of the most earthquake prone countries on the earth, Japan has invested for decades in earthquake resistant constructions, and they're expert in tsunami early warning systems, and they're very good in community preparedness training and land use plannings. So the result is that Japan regularly experienced very powerful earthquakes that cause very, very minimal casualties, because the prevention and mitigation systems are so powerful. So this country is very best example of investing more money on prevention measures rather than relief schemes. And now third one is, the third prevention measure was integration of disaster prevention into developmental policy. So we are not considering disaster prevention as burden, we are integrating into the developmental policy. So the HPC report clearly identifies a very, very crucial principle, that is, disaster prevention should be an integral part of developmental policy and planning at national level, regional level, bilateral, multilateral and international stages also. So this principle addresses one of the root causes of increasing disaster risks worldwide. See, the way the developmental activities, if poorly planned, it can increase rather than decrease disaster vulnerability. I'm repeating again. See, this principle 3, it is about integration of disaster prevention into developmental authority, mainly addresses one of the root causes of increasing disaster risk worldwide. The way developmental activities, if poorly planned, can increase rather than decrease disaster vulnerability. When new roads were built through forest without adequate slope stabilization. So they increase landslide risk, yes or no? So here we are constructing the new roads, we are building the new roads to the forest, but we are not providing the adequate slope stabilization. So they increase the risk of landslides. And I'll give you one more example. When housing developments are built on floodplains without proper drainage facilities, without proper drainage infrastructure, so they increase the flood risk. When industrial plants are located, and also when an industrial plants are located near residential areas without adequate safety buffers, they increase technological disaster risk. So by integrating disaster prevention into development planning means asking at every stage of every developmental project, does this project increase or decrease of disaster risk? These are the questions we have to pose. That is, does whatever the project we are handling, whatever the project we are about to start, does this project will increase or decrease the disaster risk? And second one, what kind of hazard exists in this location, and has this project been designed to withstand then the disaster or not? And next question, will this project change the land use or natural drainage in ways that create new hazard exposure for neighboring communities? So these are the questions we have to ask. So in India, the environmental impact assessment process. So in India, the environmental impact assessment process, which requires large development projects to assess their environmental consequences, is one mechanism through which the disaster risk considerations can be integrated into development planning. But however, the disaster risk considerations are not yet consistently integrated into all developmental decisions, particularly at the local and municipality level. This is very, very essential. And coming to the fourth prevention measure, that is early warning systems and effective dissemination. So the HPC report identifies early warning as a key factor in successful disaster prevention. So the early warning of impending disasters and their effective dissemination using telecommunication are the key factors to successfully prevention activities. See here, the early warning systems are among the most cost-effective disaster risk reduction tools available. A functioning cyclone early warning system that gives coastal population, see, um, with the help of early warning systems, we can evacuate all the coastal people 48 to 72 hours of advance, which enables the mass evacuation, which dramatically reducing the casualties. So the India's cyclone warning dissemination systems operated by the Indian Meteorological Department is considered one of the best in the world and has contributed directly to the dramatic reduction in cyclone casualties in India over the past 20 years, that is 2 decades. Here the word, the dissemination in this point is as important as the word warning. You can see here, an early warning that doesn't reach the people at risk is useless. When you are making sound in front of a deaf person, so what is the use? So here also, an early warning system that doesn't reach the population at risk situation or a disaster situation is considered as useless. So the effective warning dissemination requires the multiple communication channels in India, not only in India, in the worldwide, the multiple communication channels, which includes the radio, the television, the SMS, sirens, the community announcement systems, and the word of mouth through their trained local volunteers. These all early warning systems are used to ensure that warning should reach all the members of the population, including those without access to the modern technology era. Now, coming to the next slide, please go through the slide. I'll give you 30 seconds time, then I'll continue. Okay. So this slide presents the fifth key prevention measure, which is identified by the HPC committee, that is the role of education the role of training and appropriate development design in reducing the vulnerability. So what is that? The HPC report states that application of proper design and proper patterns of development focused on target groups through appropriate education and training is very much essential for the reduction of vulnerability. So this prevention measures has two distinct but very related components, that is design as well as education. So now let us examine each of these. The first one is proper design of development means ensuring that all the construction activities, infrastructure and land use patterns are appropriate for the hazard environment in which they are located. So in earthquake prone areas, the buildings must be designed and constructed to seismic design codes. In flood prone areas, the drainage systems must be designed for peak flood flows, not just for average rainfall. And on unstable slopes, the roads and buildings must be incorporate the geotechnical measures to ensure proper slope stability. Here the phrase focused on target groups is very significant. See here, I already emphasized in my previous lectures that not all the communities face the same hazards and not at all the communities have the same vulnerabilities. The prevention measures must be tailored to the specific hazard profile and the vulnerability characteristics of each target community. Either generic, one size fits all prevention programs are far less effective than those designed for the specific context of the people they are intended to help. And the second one, the education and training, the second component. Even the best designed physical infrastructure will fail to protect the people if those people do not know how to use it and do not understand the risk they face and they have not been trained in emergency procedures. See here, for suppose a cyclone shelter is useless if the community has not been told where it is and how to get there. And an earthquake resistant building design is useless if the contractor who builds it has not been trained in the construction techniques if required. So the education for disaster prevention must target multiple levels. At the community level, the awareness campaigns and school education programs help ordinary people to understand local hazards and recognize warning signs and know how to respond safely. And at the professional level, the training programs for an engineers, for civil, especially civil engineers and the architects and the urban planners and local government officials, they ensure that the disaster risk is considered in all technical and planning decisions. See, at the policy level, training for elected officials and senior bureaucrats creates the political will and institutional knowledge needed to sustain long-term investment in their disaster risk reduction. So India has made a significant progress in the disaster education. So by providing or by including the subject of disaster management in school curriculum is one such example. But consistent high quality disaster education at all levels remain a challenge that require sustained investment. And so I'll explain the disaster management cycle through four examples, four real case studies. So this slide for the first real examples which represents the mitigation is elevated houses in flood prone areas. This is a classic structural mitigation measure. See, in a flood prone regions like the Brahmaputra Valley in Assam, the Ganga Brahmaputra Delta in West Bengal and the coastal deltas of Andhra Pradesh and Orissa, the communities have traditionally built houses on raised platforms. So which this practice that has evolved over centuries in response to the annual flooding of these regions. And the modern versions of this approach, which includes constructing the plinth levels well above the documented flood levels. The documented flood levels will be given by the Indian Meteorological Department, and the building on raised earthen platforms and design proper drainage systems that can remove the flood water very quickly from the residential areas. Especially the Assam government has invested in raising the floor levels of schools and community centers in flood prone areas, which ensuring that these critical community facilities remain functional even when surrounding land is inundated or affected. Proper drainage systems are equally important. Many urban roads, including the recurring floods in cities like Chennai, Hyderabad, and Bombay, are not caused by river overflow, but by the inability of urban drainage system to remove heavy monsoon rainfall quickly enough. By improving the urban drainage capacity is a direct mitigation measure that can prevent enormous economic and human loss. So coming to the one more real example which is related to preparedness, that is Odisha's cyclone preparedness program. So this we discussed many times. Again, I quickly explain this one. So the Odisha's transformation in cyclone disaster management is one of the great success stories of disaster risk reduction globally. So um, today Odisha has nearly 880 cyclone shelters along its coastal area, created with concrete multi-story structures built to withstand cyclones, wind speeds, with the proper food and water storage facilities, sanitation facilities, and emergency communication required. So before each cyclone season, the government state disaster management authority, they conducts community awareness programs, and they conducted evacuation drills and the simulation exercises. The NDRF battalion pre-positioned in Bhubaneswar is trained specifically for cyclone responses. So these results only we discussed many times. The cyclone Phylline in 2013, a very severe cyclone storm similar to 1999 super cyclone, but still 1 million people we evacuated in advance. So the casualties were even less than 50. So also the cyclone Fani in 2019, even stronger, saw 1.2 million people evacuated. And here this time also less than 64 deaths were officially recorded. See, in all three cases, same hazard, dramatically different outcomes because of preparedness. The third real world example, which is related to response, that is Uttarakhand floods. So during the 2013 Uttarakhand floods, the Indian Army and the Air Force airlifted stranded pilgrims and supplied emergency food kits. So the 2013 Uttarakhand disaster, sometimes people called as Himalayan tsunami, was one of the worst natural disasters in India post-independence history. Suddenly, there is an unprecedented rainfall in June 2013 caused flash floods. That means high intensity flood accumulated within a short span of time, and landslides across the Uttarakhand hills, destroying the roads, bridges, and all entire villages. Even the Kedarnath shrine area was particularly devastated, and thousands of pilgrims who had come from for the Char Dham Yatra were stranded in remote mountain location with no road access. So the response operation that followed was of the extraordinary scale and complexity. The Indian Army, the Indian Air Force, the Border Road Organization, NDRF, the State Disaster Uttarakhand State Disaster Management Team, they worked simultaneously round the clock across a vast inaccessible terrain. The Indian Air Force helicopters, some are operating at extremely high altitude under challenging weather conditions. They airlifted nearly 1 lakh stranded people in what became the largest peacetime airlift in Indian history. The army soldiers, they trekked through destroyed trails to reach cut-off villages carrying food, medicine, and blankets. The Uttarakhand response demonstrated both the strength and weaknesses of Indian disaster response capacity. So the positive, the strength point in this was the professionalism and courage of the NDRF, Army, and Air Force teams. And the weakness is the options of adequate local preparedness and early warning systems, which meant that many people were caught completely unaware in extremely dangerous locations. And the final one, recovery example, 2001 Bhuj earthquake reconstruction. So the 2001 Bhuj earthquake, which struck on Republic Day, January 26, 2001, killed over 20,000 people and injured more than 1,60,000 and destroyed or damaged over 1.2 million homes across Gujarat. So the scale of destruction was directly related to the poor quality of construction of many buildings, including reinforced concrete structures had been built without regard to seismic design requirements. So here, the recovery operation that followed became a landmark in disaster reconstruction globally. The Gujarat government established the Gujarat State Disaster Management Authority, one of the first of its kind in India, and created a comprehensive owner-driven reconstruction program. So rather than simply rebuilding houses from a government template, the program empowered affected families to reduce their own homes with government financial support and technical guidance. Here, the Gujarat government gave financial support funding also, as well as financial support also and technical support also to the Gujarat people. So critically, the reconstruction incorporated mandatory earthquake resistant design features which appropriate foundations, reinforced concrete frames, proper structural connections and masonry wall construction practices that could withstand future seismic events. The engineers and architects provided technical training to the local masons and contractors to ensure that the new construction met seismic standards. So the Gujarat reconstruction is an example of build back better, using recovery as an opportunity not just to restore what existed before, but to create a safe and more resistant, resilient built environment. So this is the gold standard of post recovery, post disaster recovery. So the final part of the lecture 4, that is disaster mitigation. See, along with the preparedness and prevention measures, the mitigation measures are also essential to deal with the disasters. See here, the opening statement of this slide is very, very important. That is, along with preparedness and prevention measures, the mitigation measures also very much essential to deal with the disasters. This acknowledges that mitigation does not replace preparedness and prevention. It complements both the preparedness and prevention. So a comprehensive disaster management strategy requires all the three things, that is preparedness, prevention and mitigation. So the former definition on this slide, mitigation refers to the all the actions taken before a disaster to reduce its impacts, including preparedness on long-term risk reduction measures. So notice the phrase here, that is before a disaster. Mitigation is fundamentally a proactive activity. While some immediate mitigation actions may be possible during a disaster, such as sandbagging to slow advancing flood water, the most effective and impact mitigation measures are those which implemented in the pre-disaster period. So mitigation activities fall broadly categories into two categories, the structural mitigation and non-structural mitigation. So this distinction is one of the most important conceptual framework in disaster management, and you will encounter it repeatedly throughout this course and in your professional career. So what is structural mitigation? So the structural mitigation refers to the physical measures, that is the construction and engineering inventions that physically reduce the disaster risk. So the structural mitigation is a domain in which civil engineers, geotechnical engineers, structural engineers, and urban planners play their most direct and impactful role. The examples which includes earthquake-resistant building designs, the flood embankments and levees, cyclone shelters, landslides, retaining walls, and fire breaks. These all are comes under structural mitigation. Then what about non-structural mitigation? So non-structural mitigation refers to the measures that do not involve physical construction but instead address disaster risk through policies, through planning and through behavior and through institutional change. So here non-structural mitigation, which includes land use planning and zoning, building codes and regulations, the early warning systems, public awareness and education, and then insurance mechanisms and community-based disaster risk reduction programs. These all are comes under non-structural mitigation. So an important concept introduced on this slide, that is non-structural mitigation, is described as a man adopts nature approach. So here I mentioned a man adopts nature approach as opposed to structural mitigation, which attempts to engineer nature to accommodate human settlement. Also, the non-structural mitigation accepts the reality of natural hazards and focuses on adopting human behavior, land use, and construction practices to reduce the exposure and vulnerability to those hazards. The both structural and non-structural mitigations are necessary. The physical structures without proper planning and regulations are insufficient. An embankment can be overtopped if land use in the floodplain is not regulated. And the regulations without physical infrastructure also equally insufficient. A land use plan that forbids floodplain development is useless if the existing residents of the floodplains have no safer alternative. Yes or no? So now, so these are the structural mitigation. The structural mitigation of disasters refers to the use of physical structure, physical structure, engineering techniques, and construction practices designed to reduce to prevent the impact of nature and man-made disasters. Here you can see the building here. The first one is um, you can see here earthquake resistant buildings, the flood control structures, cyclone wind protection, the five breaks and retardant structures, the volcano and landslide mitigation. These all are comes under structural mitigation. So coming to the non-structural mitigations, the public awareness and education, land use planning and zoning, building codes and regulations, the early warning systems. So whatever we discussed in the last slide, so that comes under non-structural mitigation. So with this, I conclude the unit 4. I'll quickly summarize. In this lecture for all part A, part B and part C, we covered the concept and different stages in disaster management cycle, that is pre-disaster phase, during disaster phase and post-disaster phase. Disaster preparedness and key concepts of disaster preparedness, and then disaster prevention and mitigation measures, which include structural mitigation and non-structural mitigation.